right, here you go. What is the area to the figure on the right? So instead of perimeter this time, you're finding the area. How do you find the area of the shape? What do you need to do?
Add all the sides.
We do not add all the sides. To find the perimeter, you add all the sides, but we're finding the area. Multiply. Multiply the length of one side times the width of another side. So you're multiplying. Then you're solving 13 and 45 hundredths minus 27 and 21 hundredths. That will be a negative answer. Number 3, what are the factor pairs of 40? The numbers that multiply to 40. Number 4, find the sum of the least common multiple and the greatest common factor of 12 and 18. And number 5, 98 hundredths divided by 2 hundredths. Also, taking one off because I don't want to do it. Figure to number 2 here. I don't want to do number 2. That's okay. We'll just do 3 or 4 problems right now instead. Okay. Yeah. So there you go. Do 1, 2, 3, and 4 on this instead of 5 problems. So go ahead and be working on those, please. Yep. Once you find the GCF and the LCM, add them together. No, the answers. Like find the LCM of 12 and 18, find the GCF of 12 and 18, and then add your answers together. Yeah. Give it about 3 more minutes. About 2 minutes. Okay, let's go ahead and go over these so we can get going on some math today. All right, so number 1, we are finding the area of a rectangle, which means that we're figuring out how much space this rectangle takes up. You're going to take 30.25 and multiply it by 7 3/10. So 30 2500 times 7 3/10. So we need to do that multiplication. What is 3 times 5? 15, carry a 1. What is 3 times 2? 6 plus 1? 7. What is 3 times 0? 0. And 3 times 3? 9. Good. What do I do next? Multiply it by the 7. Good. So what do I have to add here? My placeholder 0. Then we can do 7 times 5. What? 35. I thought I heard 85, and I was like, whoa, no. For the area, you multiply. For the perimeter, you add. Yep. Now we need to do 7 times 2. 14 plus 3? 17, carry 1. What is 7 times 0? Plus 1? 1. And 7 times 3? 21. We can add now. What's 5 plus 0? 7 plus 5? Well, carry 1. 1 plus 7? 8. 1 plus 7. 1 plus 9? 10, carry 1. 1 plus 1? And 2. So it's 220,825. No. Yeah, we need to move our decimal. We have 1, 2, 3 behind the decimal up on the top, so we need to move it 1, 2, 3 times down below. You get 200. Oh, that's not right. You get 220 and 825 thousandths. Right here? Here. They can't. Huh?
They're half of the,
Which part? This way?
yeah.
I need to go that way? Okay. All right. Number 2, we need to find the factors of 40. What numbers multiply to 40? Start with the basic. Start with 1. 1 times what?
40.
1 times 40. 2. Does 2 go into it? 2 times 20. Does 3 multiply? No, listen to what I'm asking. Does 3 multiply to 40?
No.
What about 4?
Yes.
4 times? Okay, what about 5?
Yes.
5 times 8. What about 6?
No.
7?
No.
Nope. And then we hit 8 again. So we're done. Good. That was a quick one. Number 3. We need to find the greatest common factor and the least common multiple of 12 and 18. So we need to do our factor trees first. What numbers multiply to 12? 6 times 2. We circle the 2 because it's prime. Wake them up. Oh, wake them up.
All right.
Good. What multiplies to 6? 2 times 3. Both of those are prime, so we can circle them. Next one, 18. What multiplies to 18? 2 times 9. Good. We can circle our 2. What multiplies to 9? 3 times 3. Good. So now let's do our LCM and GCS thing. So I'm going to put the numbers for 12 on top, 3, 2, and 2. And let's match. Is there a 2 to match?
Yeah.
Yep. Is there a 3?
Yeah.
Yep. Is there another 3?
No.
Nope. So where do I put it? On the top. Now, yeah, okay, we need to multiply. Multiply all of them. So what is 3 times 2 times 2 times 3? 3 times 2 is 6. 6 times 2 is 12. 12 times 3 is 36. So our least common multiple is 36. What? 6 times 6 is 36.
Did you multiply all of them together? I accidentally put down 10.
Ah, that would be it. That would be it. Yeah. All right, and then our greatest common factor is 3 times 2, which is 6. But now, the question was asking for the sum of these. If I'm finding the sum, what am I doing? We're going to add our numbers together. And 36 plus 6 is 42. There's our answer.
Can we just like add the top two?
What do you mean add the top two?
Add both of them. That's 12 times 18.
12 plus 18 doesn't equal 42 though.
That's 30. Mm-hmm. But I'll multiply them.
No, it's way too big. You gotta do what we did.
Okay.
Why is mostly in the LCM and GCS like sometimes there's a lot of twos in it.
It's a lot of 2s and 3s because that's one of the smallest prime numbers. So they use a lot of 2s and 3s in prime numbers. Yeah. Hmm.
You still get the answer. You
Maybe. Depends on what you did. Like if you did these differently? Oh, like if it was 3 times 3 times 2 times 2, you would still get the same answer, yeah. All right. Number 4, we are taking 98 hundredths and dividing it by 2 hundredths. Before I can do anything, I need to move my decimals. What do I do first? Good. Bounce the ball to the wall on the outside. If I move it twice on the outside, how many times? You absolutely have to move it twice on the inside. and then you need to bounce it to the top. Good. So if you move it twice on the outside, move it twice on the inside. If you move it 4 times on the outside, move it 4 times on the inside. You always move it the same amount. So now we can do 2 and divide that into 98. Does 2 go into 9?
Yeah, 4 times.
4 times. Subtract and get 1, drop down your 8. Does 2 go into 18?
Yeah.
9 times. Evenly. So our answer here is 49.
Wow, that was real fast.
That was a quick one.
Only got 2 in one.
That's okay. The point is that we just practiced them. All right. Now, we have been learning about algebraic expressions.
I think he actually wanted to do that.
So we've been learning about algebraic expressions, and on Google Classroom, under math, yep. So under classwork, under math, hopefully it posted. Reload your page if you need to. Let's see. There we go. Evaluating expressions notes. So go ahead and get that open, please. Evaluating expressions notes. And it's a Google Doc. You guys should all have your own. Okay?
We're in math, right?
We're going to learn how to solve and simplify algebraic expressions today. So we're going to talk about that. I'm going to give you a minute to get there.
No, I got
Form on cover. Computer's not working.
Is this still not working? Let me print it out for you then really quick, okay? Before we get started. All right, give me 1 minute. I'm going to get this printed. I don't know what's wrong with it.
Yeah, turn it up.
She probably had it because by the time we came back inside, it was still on.
You think you're a brightness that we love? What's your brightness? Is your brightness low?
Okay, so let's go ahead and look at these.
Okay.
All right. So, to start off on our notes, we're going to just kind of talk about some words that you're going to see when we talk about adding, subtracting, multiplying, or dividing. I'm going to type these out. So when you are thinking about addition and adding, what sort of words are you going to see during that? Like keywords that tell you need to add. Okay, we can find the sum, total. No, you do not need to write your name.
All together?
All together, good. I'm gonna turn my sound up so I can hear you guys very well. That works too, yeah. Huh. Okay, that's good. Just keep the papers. How many might be good? Anything else? How much? What about
How much total?
more than? We saw more than yesterday.
How much total?
We have both of those on there already. Maybe. Okay, I think that's a good list. So these are some that we might see for adding. What about subtraction? What will you see with subtraction? Difference.
Less.
Less than. Might see less than. What else might you see?
Different.
We already have difference. Smaller might be one. What about takeaway? Take away this from this. Skylar.
How many are
Like how many are left, maybe? Okay. I think that's a pretty good list again. Can't reach it. All right, what about multiplication? When we're talking about multiplication, what do we look here? The product. Find the product. Times as much. That's a good one. I'm going to zoom in. I didn't think about that. Sorry. Times would be another good one. Sometimes they straight up just say multiply, yeah. What else might you see?
Greater than? No.
That's more if you're going to compare things, like this compared to this. Anything else? All right, it works for me. All right, and division. What do we see with division? We see the word divide. Good. Quotient is the answer to a division problem. If you're dividing things between people, what are you going to do? What's another word for divide? Split. Good. Separate. Anything else that kind of jumps out to you? Groups is good. How many groups? Yep. Because sometimes they'll be like, how many groups of students can go on the bus? I don't know. I just kind of made that up. That's not a very good example. Yeah. How many overall is a pretty good one for most of these? How many are left? How many total? How many when you multiply? How many when you divide? Yeah. How much is another one that kind of goes for all of them, but that's all right. Usually when they ask how many, they give you other keywords that help you know which operation you need to use. Okay, I think that's a good list for that too. I'm going to give you about 1 minute to finish typing those out. We kind of did those quick, and I type fast, I know that. So I'm going to give you about a minute. I'm going to drink some water. So you play it to get better.
You gotta write like all of them down, like just like a few.
If you have more, you can write them down as well, but as long as you have most of what I have, you're good. Is it not working, Bradford, at all? You can't type on it? Okay, use the paper copy. Bradford, you might have to just follow along and maybe try some of them later, but just follow along if it's not working, or maybe try reloading the Google Doc a couple times, something like that. Okay, sorry it's not working. Oh yeah, sorry. right, I'm just going to scroll down a little bit.
Just a little.
So what we're going to do is practice and learn how to solve when you have a variable and it gives you a number to plug in. So it's going to give us an expression like 5x plus 4. Well, they give us n, right? So maybe it's 5n plus 4. We're going to evaluate when n equals 2. So we're going to plug the number 2 anywhere we see n. And then we're also going to evaluate when n equals 5. So anywhere we see the letter n, we're going to plug in the number 5. It's called substitution. I'm also going, sorry, too far. I'm going to highlight this right here because this is what we're going to do. Evaluate for n equals 2 and n equals 5. I'm just going to highlight that blue just so that we can find it easily when we need to. Okay, there is an example that we're going to go over after we talk about the little notes section. Am I good to scroll past the words or
Yeah.
not just yet? Okay, I'm going to give it a little bit more time.
I was really excited this morning. I was like, Alex.
I know. All right.
I thought I wanted to do more, but I have to do it. And I was like, say more.
All right, I'm going to leave it right there just so that we can look at these notes that are right here. There's not a ton of notes to go over for substitution. It just takes a lot of practice. For substitution, the first thing you're going to do is replace the variable, whatever letter it tells you, with the number it gives you. So for the example we're going to use, all of our expressions are going to use the variable n, the letter n. We're going to take out the n and plug in a 2 in its place. So we take out the n, plug in 2, and now you have all numbers and you can do order of operations to find your answer instead of a variable. So they're telling us what our variable equals so that we can plug it in. That's essentially what we're going to do multiple times today to practice. Am I going to scroll past this now?
Yeah.
All right. So down here in the example, they tell us that the phrase is 4 more than a number. And when you write that as an expression, you get 4 plus n. There's 4 more than whatever number n is. 4 plus n. Then in the first or the third box, it says to evaluate for when n equals 2. So our first line here says 4 plus n. The second line says 4 plus 2. Where did they get the 2? N. They said n equals 2. They took out the n. The n disappears. You don't need it anymore because you're replacing it with the number 2. And then you can just solve. 4 plus 2 is what? 6. No, it'll tell you what number to replace it with. So in this case, you can't really replace it with anything. Later in your algebra career, you will. But, huh?
So in the first box, we can the n to 2, and then the second box to 5.
Mm-hmm. So the first one, when n equals 2, we replace the letter n with the number 2, and then we can solve. 4 plus 2 is 6 to get our answer 6. In our second box, when n equals 5, you take your n in your expression, replace it with the number 5, and we can add. 4 plus 5 is 9. It won't highlight, but there's the 9. So we're essentially just taking out our variable, getting rid of the letter and replacing it with the number they told us it was. I like to explain it, talk about it in terms of money. Let's say you have $1, like $1 bill, right? And you want to go to the arcade, but you need quarters. What are you going to do? Huh? Go to the cashier and you're going to ask them for what? How many? 4 quarters. You can give them $1 and they'll give you 4 quarters back. It's kind of the same thing with these variables. It tells you that the n is worth 2 quarters or whatever. So you plug in those 2 quarters and take out the n. So it's just a replacement. They mean the same thing. You're just replacing it with a number instead. Does that make sense? If that confused you, then ignore it. Okay? So we're going to practice this now. Part 2, our second one says, a number decreased by 10. What does the word decrease mean? Subtract. Now the key when you see anything that says a number, it just means the variable. You don't know the number, so it's your variable. So a number is just n. It's the number you don't know. It's your variable. I don't want it. No, it doesn't matter. So if it's uppercase, you're okay. So any number decreased by 10. So we said decreased means subtract. How many am I subtracting from n? 10. A number decreased by 10. Okay. Yes, these are notes you'll keep, yep. So then, we have n minus 10. That's our expression. N minus 10. Like I said, it's okay if it's capital. We need to take out the n and replace it with what first? What's the letter for this column? 2. We're taking out the n and we're replacing it with 2. So we're going to write 2 instead of n. The n is gone, replacing it with 2. Oh, and then we still subtract 10. Now we get to work with integers and do 2 minus 10. It is negative 8. If you start at the number 2, let's see. So I don't know if you guys can see the number line, but if you start at the number 2 and you subtract 10, you go backwards 8 on your, backwards 10 on your number line, you end up with the number what? Negative 8. Good. So we have replaced n with 2, and then we can do 2 minus 10. All right. For our second box over there, I'm going to get rid of some of these lines. For our second box, there we go. All the way at the end, it says evaluate when n equals 5. So we have the same expression, n minus 10. Same expression. If n equals 5, what am I going to replace n with? Well, this time we're using, when n equals 5, we replace it with 5. So you replace it with whatever it tells you your variable is. In this case, 5. And then we need to do 5 minus 10. This one is negative 5. You start at 5 on your number line and you hop backwards 10 times and you're going to end up at negative 5. Good. I'm going to give you a second to write that one out. How are we doing? Is this making a little bit of sense? Okay, what about online? Is it making a little bit of sense? This is kind of a hard concept, so making some sense?
Yeah.
Good. All right. Let's look at our next one. This one is a product. What does product mean? Multiplication. A product of 5 and a number. So we are using 5 and we're multiplying it times a number, but we don't know what the number is. So what am I going to use? N, our variable. 5n. Remember that when you see a number smushed together with your variable, it just means to multiply. There's an invisible multiplication symbol in between. 5n, 5 times n is what it's saying here. The product of 5 and a number is 5 times n. 5n. Then, for our next box, we know that n equals 2, so we're taking the number 5, and we need to multiply it by what? What are we replacing our n with? 2. But if I just write the number 2, it looks like 52, right?
I can put 5
You can put an x, but now the issue is we're using variables, and x is a very, very, very common variable, one that you see all the time. So someone could say this is 5x2, 5x squared. Someone could confuse this. So typically what you see is they will put it in parentheses instead to show you that you need to multiply 5 times 2. Because we know that parentheses next to a number is invisible multiplication. There's a lot of invisible multiplication with variables. So instead of writing an x as multiplication, because that could be mistaken as a variable, we put it in parentheses instead. And then we can solve. What is 5 times 2? 10. And that's it. Let me get rid of some of these extra lines. All right, so 5 times 2 is 10. In our next box, we are doing, or we're replacing n with what number now? 5. So we have 5 that was originally there. I guess I forgot to put the original one up on here, huh? 5n. So original is 5n. When we replace 5, or n, with 5, we get our invisible multiplication. What is 5 times 5? 25. Perfect. I remember yesterday when Miss Daphne was saying that some people, like, one of the common mistakes we see is that when you guys plug in numbers for this, instead of saying it's 5 times 5, you'll say it's 55. That's one of the most common things that we see, that you'll plug in. So let's say we're looking at our 5n right here, and you say it's 5, and then we're replacing our n with 5, and you get 55. That's one of the most common mistakes, that you think that it's 55 instead of 5 times 5, because 25 and 55 are much different numbers, right? So keep that in mind, that when you replace the variables, that you're multiplying and not just putting in, suddenly making it a new number, okay? All right, how many more do we have here? A couple. Yeah, go ahead.
We have 2 more?
No, hang on. I just want to see something really quick.
Okay.
Sit tight. I just want to see what we're doing tomorrow. So I want to see what we need to learn today. I don't remember exactly what we're doing tomorrow. Okay. So we should be okay. Let's keep going on this. Let's do these last 3, and then we'll probably be okay. Yeah, we're only going to do these 3. I don't think I want to keep going and do all of these extra ones down here. There's a lot down there. I think I would rather we just practice with these 3, and then we'll do quizzes tomorrow to practice and review those quizzes. Yeah. All right, so let's talk about this next one. 4 times a number. What does the times tell you you're going to do? Multiply again. So we're taking 4 and multiplying it by a number. Do we know what the number is? No, so we need to put our variable. Good. It's our unknown number, so we put our variable there instead. Good. Then on our next one, we know that They want us to replace n with 2. So we have 4n as our first one. If we're replacing n with 2, how am I going to write this? Someone tell me how to write this. Elijah, go ahead.
Four parentheses.
Two parentheses.
Good. 4, because we're multiplying 4. Parentheses means invisible multiplication. So we're doing 4 times 2. This doesn't come out as 42. What is 4 times 2? 8. Is this the more we do it, is it making more and more sense? A little bit? Good. Okay, I'm going to get rid of some of these extra lines. That's not that many. Okay, our next one. We still have 4n as our expression. Then we need to replace n with what number now? 5. We're replacing n with 5 this time. So we have 4, invisible multiplication with our parentheses, times 5, because we're replacing it with 5. What is 4 times 5? 20. Sorry, I thought I heard that thing start to go off. Good. All right. Uh-huh. Whew.
Long day today.
I know the morning has felt a little bit long, huh?
Yeah.
All right, let's look at our next one. A number divided by 6. Just for these examples. It won't always. Yeah, I'm going to have to show you guys how to do the division sign. How am I going to write this? What does it mean when I say a number? N. It's not 6n. We're dividing this time. We need to do a division sign. So to insert a division sign, you go to Insert up at the top, and then you go to Special Characters. So Insert Special Character, and then it gives you all of these options, right? There's a ton on here. It just keeps going and going and going. In order to find it, you look at the search part and you type in div, because that starts the word divide, and then it should pop up. I like to use this one, the small division one, to write that, and then you just click on it and it appears in there for you. You don't. If you click it multiple times, it'll appear a lot of times. Once you click it once, just hit the X, and it's there. See, I hit it multiple times, so I have lots. Sure, that's fine. Is it big? Okay. Okay. So we're taking a number and we're dividing it by 6. N divided by 6. Good. Did you guys all find the division sign okay? I'll show you guys one more time if you're looking for it. To find it, you go to Insert, Special Characters, and then to actually find the thing, you have to kind of start typing in the word divide, D-I-V, and it should start to pop up. And you should be able to click on one of those division signs. There's the big bubble one, and then there's the smaller one. There's a circled one. I don't know why. I don't use the circled one.
I use that one.
Oh, I thought you might use this one. Oh, well. Just know you need to divide. All right. So n divided by 6. Our next one. You might want to just copy and paste it over now that it's there, so you don't have to find it again. N divided by 6. Copy and paste that over. We need to do our replacement here, our substitution. We know that n equals 2 for this column. So what do I need to replace n with? 2. We need to divide it. I'm going to copy and paste the division sign. Divided by 6. Now we can make this a decimal. You won't get a negative number. You get a decimal. What is the decimal when you divide?
0.3.
It is. When you divide this, you get 0.33.
What? John, don't you get 0.3 because you can. Wait, how though? I don't know.
2 divided by 6. Let's do it behind me. Can you see?
Yeah.
2 divided by 6. The 2 has to go on the inside because it's first, right?
Oh,
2 divided by 6. Does 6 go into 2? Nope. 6 doesn't go into 2.
No.
And then we can put our decimal and our 0. Bring up our decimal. Does 6 go into 20?
No.
How many times? 3 times. You get 18. You subtract 2. You get 2. Drop down another 0. You get 20 again.
Oh, yeah.
You get another 3. And you do it again. And you drop down another 0. And you get another 3. It's a repeating decimal. It'll go on and on and on forever. Huh?
I thought it was 1. Or it's running with 1. So I did so I put 3.
Mm.
I didn't look at it.
That's okay. So our decimal here is 0.33, 33 hundredths. It will just keep repeating and repeating, so we'll just leave it as 0.33. Yes, Charlie?
That is like that, but then repeat like do that go on and on and on and on and on.
I mean, we do that sometimes.
Yeah.
We have before.
But it's not repeating.
Maybe. We'll see. All right. Our next one. We are going to replace n with 5 this time. So I'm going to copy and paste n divided by 6 again. So now n is going to equal what number this time? 5. This time it's 5. And then I'm going to copy and paste my division sign again. 5 divided by 6. Now, we can make this a decimal like we did the last one, but also 5 divided by 6 is a fraction, 5/6, and we can do that too.
I did 0.3 though.
5/6 is 8.3. 5/6 it doesn't come out to 0.3.
Yeah. I divided and I got that.
You divided 5 by 6 and got 0.3? It should be,
No, 0.83.
oh yeah, that sounds right. It does have a division sign, it's just not on the keyboard.
Insert.
Yep. So instead of doing the division, we can just make it a fraction 5/6 because we know that 5 over 6 is really 5 divided by 6 if we wanted to make it into a decimal.
Wait, how do you do that?
I just typed out 5/6 and then you hit the space bar and it does it for you.
That's a new update from.
Yeah. If it doesn't do it, I still know that 5/6 means 5 divided by 6. Yeah. All right. We have one last one we're going to do, and then we'll be done for the day because we got to go pretty soon anyway. Our last one. 5/6. I am. I have it all week. Can you guys put your chairs on the floor, please? Thank you. Our next one is 7 times a number plus 4. Huh? Yeah. Let's start with 7 times a number. What does it mean if I do 7 times a number? 7 times n, which we can just write as 7n, because we know there's invisible multiplication there. 7 times n.
Wait, do they keep the X the times thing just to make it not as confusing?
Yeah. They take away the multiplication symbol so it doesn't look like the variable x. Yeah. And then it has us doing plus 4. That one's a pretty self-explanatory. What am I going to add here? Plus 4. An addition sign, 4. Plus 4. 7 times a number, so 7n plus 4. No. We all want to take a nap, but we're not going to.
I did one.
I did.
Okay, let's go ahead and finish this up. This is on my hand. All right. So now we're going to write 7 and plus 4 again. On our next line, we need to replace the letter n with what number this time? N equals what in this column? 2. We need to replace it with 2. And then we still keep our plus 4 at the end. So this time we have 7 times 2 plus 4.
Is there a way you can do PEMDAS with algebra?
Yes, right now we need to do PEMDAS because right now we have a multiplication and addition. So what should we do first? We should do those parentheses, that's multiplication. What is 7 times 2? 14. Plus 4. And once we finish that out, we get 18. Now, one of the common mistakes I see here is this second line right here, right? Where it's 7 times 2 plus 4. Like Ms. Stephanie pointed out earlier, this is not 72 plus, oh wait, sorry, hang on, hit too many things. Reset. This is not 72 plus 4. That's 76, that's not our answer. So you need to be careful with this step, that when you plug it in, you remember that you must multiply here. It's one of the biggest mistakes that we see as 6th grade teachers. Does that make sense? Okay, good. Ms. Daphne is absolutely a teacher, yes. I would not say that to her face. 7n, very quickly. Our last one, we have 7n plus 4. On this one, we need to replace n with what number this time? 5. 7 times 5 plus 4. Don't forget that plus 4 either. That's another thing. You guys sometimes forget to bring down the rest of the expression. What is 7 times 5? 35 plus 4. What is 35 plus 4? There we go, 39. Good.
36.
Alright. That's right. I love algebra. I think algebra is a lot of fun.
Algebra is hard.
It is hard, but I think it's fun. So, we're going to do a lot of practice with this tomorrow as well. We're going to practice. Yeah, you can. We're not going to do the bottom part here. So you guys can turn it in when you're done. You should still be able to see the notes if you need them. So you can turn it in. Those of you that are online, you guys can head out, and we will see you at 12:30 for science.